Lesson 8.5.15, Spheres, Volumes of Spheres. In this lesson, we'll compare the volumes of a cone, cylinder, hemisphere, and sphere. When the volume of a sphere, and we'll also find the volume of a sphere when you know the radius or the diameter. All right, big finish to our unit. We're on page 56. And let's just restate those learning goals. You're going to compare the volumes of the things that we've learned about. Compare the volumes of, well, we started with cylinders. We went on to cones. And in the activity today, we talked about hemispheres, which is just half of a sphere, and spheres. Wow, ran out of room there. And once again, armed with a formula, you're going to find the volume of a sphere. When you know the radius or the diameter. By now, you know that if you know the diameter, you know the radius. In fact, I'm just going to put that in parentheses. Now, these notes really focus on mistakes that you can make in using a formula. I know you know by now how to use a formula for volume, but I see little boo-boos all the time. So we're going to compare these characters, Daryl, Nyla, and Maya. They calculated the volume of the sphere on the right here, and each of them made an error in their calculations. So we're going to see what their errors were, learn from their mistakes, and do it the correct way. Now, I'll remind you that the formula for the volume of a sphere is 4/3 pi r cubed. And I know that seems a little odd, but there is a reason that it's like that you might see when you get into a high school geometry course. But there's our formula for the volume of a sphere. So let's go ahead and see what people might have done. The only information you really need to find the volume is the radius. And I can see that the radius is 6 for this sphere. So all three of these people did a fine job of plugging 6 in, but all three of them did something wrong. So let's start with Daryl. Daryl said the volume was 4/3 times pi times 6 cubed. I'll remind you that means 6 times 6 times 6. Let me zoom in just a smidge here. And when he simplified it, he wound up with 4/3 pi, okay, that looks right, times 36. Well, something seems a little off here. And I think what it is he was so used to doing pi r squared, he just did 6 times 6. That's 36. But we need 6 times 6 times 6. That's 216. So that was our first mistake. When he cubed the 6, he didn't really cube it, he just squared it. So Daryl found 6 squared, that's a squared, which is just 6 times 6, instead of 6 cubed, which is 6 times 6 times 6. Okay. So we'll be sure not to make that mistake. If it says to cube it, we'll multiply it by itself 3 times. All right, let's take a look at Maya and see what she did. Well, once again, she substituted in the radius just fine. 4/3 pi times the radius cubed. And when she simplified it, she got 4/3 wait a minute, 18.8. I bet I know what happened. I bet what happened was Maya didn't follow the order of operations. I'm just going to check here. I bet she took 6 times 3.14. Yep, that's what it was. There's the 18.84. So her mistake was not following the order of operations. Just highlight where the mistake that she wound up with here. Order of operations says you need to do exponents before multiplying. So she should have raised the 6 to the power of 3 before she multiplied by anything else. So Maya did not follow the order of operations. So that's another thing I need to remember to do. Exponents first. Exponents first, and when you do the exponent, do it carefully. Oh, all right. Let's find out what Nyla did. Once again, substituted in that 6, perfect. What might have been the problem here? Got 4/3 pi times 18. Where did the 18 come from? Can you figure it out? This is a really common mistake, actually. Oops. Here I am trying to vary my highlighter colors. Do you see what she did? She multiplied 6 by 3 instead of multiplying 6 by itself 3 times. So Nyla found 6 times 3, not 6 times 6 times 6. 6 where it appears as a factor 3 times. Okay. So I know what mistakes to not make. I need to make sure I raise it to the 3rd power. I need to make sure that I know what that means. And I need to follow the order of operations. So let's go ahead and find the sphere the right way. So the volume was equal to 4/3 pi times the radius cubed. And let's go ahead and start filling in values. 4/3 pi times 6 cubed. Well, 6 times 6 times 6 is 216. So let's simplify this. And quick little lesson in multiplying these things together. Zoom in one more time. I'm just going to multiply 4/3 by 216 over here on the side. Now, the math teacher in me wants to cancel some things with the 3 and the 216. But if you're not comfortable with that, here's what we can do. Multiply 4 by 216. And in the denominator, 3 times 1. And then just divide. 864 divided by 3 is 288. All right, so I multiplied 4/3 times 216, and I got 288. And don't forget the pi. So that's the volume in units cubed of that sphere. So, what advice would you give to a student to help them find the volume of a sphere? Well, I think it's all about carefully evaluating that exponent. Carefully evaluate the exponent before anything else. There's still mistakes you can make. That's why I said carefully evaluate it. But don't let it trip you up. All right, so that ends our little unit on volume. Enjoy the homework.